So the last section of Chapter 9 is solving nonlinear systems. Now you've solved systems in the past, such as an example like this. These are two linear equations though. So a system just means more than one equation. In this case they have this line and this line. We want to solve them, meaning if we were to graph them, where would they intersect? So one option for solving this is we could just get y by itself and graph it, but that could be a lot of trouble. So I'm just going to review quickly a method you've learned about previously. What I would notice here is that these are set up for elimination. So all I need to do is, I'm going to multiply this top equation by 2, and the bottom equation I'm going to leave alone. So if you notice, when I multiply the top equation, everything by 2, you'll get 4x plus a 2y, and 2 times 7 is 14. So I changed it a little bit, but I'm allowed to do that because I multiplied everything. The bottom equation I'm going to keep the same. Now you can see why I did that. These here don't cancel or eliminate, but the y's do. I have a positive 2 and a negative 2. So when I add these equations together, 4x plus 4x is 8x, 2y minus 2y cancels out, and 14 plus 2 is 16. Now I can easily solve for x, just divide both sides by 8, and x has to be 2. Now that I know x, I can find y. So I can pick either equation. I believe I picked the top one here. And I'm going to plug 2 in for x. So 2 times 2 is 4. And just minus the 4 over to get your y value. So I have x and I have y, which means that these would cross at 2, 3. If I were to actually graph these, they would cross at this point. So it should be a review of the elimination method. I'll also show you the substitution method, but I want to show how it relates when we have a system that is one is linear and one is quadratic. So this could be looks a little harder. I will show you this method. I do not expect you guys to use this substitution method. I'm going to show you an easier way, but just hang with me, okay? Just to see how this would work. So if I were to do this, I would notice that both are equal to y, so these have to be equal to each other. So that's what I would do first. I would set 2x squared plus 5x minus 1 equal to x minus 3. And we have a quadratic, and in order to solve a quadratic, I'd have to move this x over and move this 3 to the other side. So when I combine things, 5x minus 1x is 4x, negative 1 plus 3 is 2, it's equal to 0. And now I could use factoring, quadratic formula, any of those methods we've talked about in class. What I'm actually going to do is divide everything by 2 because I notice that everything is even. And when I do that, it reduces it to a little bit easier to work with. Once again, I could use quadratic formula, but I did notice that this one is actually factorable. 1 times 1 is 1, and 1 plus 1 is 2. Once something is factored and equals to 0, we can set both parts equal to 0 and solve. In this case, they actually give me the same answer. X is equal to negative 1. Okay. What I can do is plug that back into either equation. Bottom one is probably going to be easier. So let's put that negative 1 in there. Okay, I just serves the bottom equation, plug in the negative 1, and so my y value has to be a negative 4. So in other words, these would intersect at the point negative 1, negative 4. Now that's a lot of work, okay? And I would recommend that you guys find, the smartest and easiest way to get an answer, which would in this case would just be graphing. We could just graph both of these answers and see where they intersect. So let me pull up the calculator here. And I'm just going to type in my equations. This should be a lot easier, okay? 2x squared plus 5x, make sure you type in everything correctly, minus 1, and then x minus 3. Notice the first one's quadratic, so it should be a parabola shape. So we should see this parabola, quadratic equation. And then here's my line coming across, and ooh, look, they do intersect, just one little point right there. And here's what I could do. Hit second graph. We're looking at the table. I want to see where their y values are the same. And they're not the same here, but if I scroll up into my negatives, look at negative 1. These y values are both negative 4. They cross at negative 1, negative 4, which is the answer I had. So you can, in an easier way, you could do all this work if you want to. I would recommend you just graph it, look to see if they actually intersect, and try to figure out from the table where they have the same y value, and that is your answer. A lot easier, right? Just a reminder, here's the different possibilities. We saw that you could have just one answer if they just kind of intersect once. There could be two answers. If you draw a parabola and a line going through it, it could intersect twice. And there could be no solution if they don't intersect at all. Okay, so graph it and see which situation's happening. What I would recommend is that you guys try out these on the next page. These are the same as what's in your packet, so I believe it's page 19 for you guys, but I'll just zoom in there a little bit. But just solve these. So my recommendation is just graph both equations, type it in correctly, and see if they intersect. They could intersect at 1 point, 2 points, or none at all. All right. Hope that helped, and bring questions to class, and we will try these out and check your answers when we get back together.